In chapter 16, we're going to talk about safety. Paul gives us an anonymous quote here. We obey the laws to stay in business, but we obey the laws of physics to stay alive. That makes perfect sense. There are things that we need to watch out for when we're working with wind energy, that include, remember, when we're installing this equipment, you're working on a construction site. The obvious safety issue is probably falls. With any equipment, we're going to run into mechanical failure. Wind is no different. We are generating electricity, so it's possible to be shocked, even if the equipment is shut off. Sometimes when we're working on equipment, we may do one thing which releases mechanical energy which could harm you. Mother Nature is always going to be an issue because turbines are installed outside in some of the most gruesome conditions. And then lastly, we have to get to where the turbines are installed. So travel can be an issue, as can fatigue. So like I mentioned, this is a construction site. Primarily, any wind installation is more of a construction site than anything else. We have to get the thing installed, which means we may need to bring in more than likely excavation equipment. And so since we're going to be doing digging, if we have to crawl down into these holes, we have to be very careful about how we do this, because if you dig a hole, it's possible for the soil to give way and fill you in with it. The foundations for some of our larger towers are surprisingly deep. And so because we're digging these holes, it's not hard to fall into these holes. So safety issues abound here. We have to make sure that we have adequate boundaries and fall protection, which we'll get to here in a moment. When we're doing our foundation work, before we put in the cement, there's almost always going to be some rebar reinforcement. And that rebar is an easy thing to trip over, or if you were to fall on it, you could be impaled by it. Remind me to tell you the story about my friend Torsak. Because it's a construction site, we have to remember that when it rains and it's been dug up, it's going to be slippery and it's not hard to fall. And that's why we may fall and slip into a hole or fall onto a piece of rebar or whatever. And then, of course, because it's a construction site, we'll be using all sorts of machinery, which requires many of them have their own unique safety requirements. So there will be hearing issues, welding issues, electrocution issues, all sorts of things can happen on a construction site, and we need to be careful of all of these. So Paul doesn't mention that very much in his book. However, the first thing that he mentions is what's covered here on this page, and that's falls. On page 360 of the book, he shows us a picture of Terry Merkham. Terry Merkham was killed, and here is a shot of him. Boy, that just doesn't look very safe, does it? So why would a person who's got all this experience working on wind machines do something like this? Now, granted, this is 1981, before some of the safety harness laws came into effect, but wouldn't you think common sense would take place? You'd think so. So there's two ways where falls are going to occur. One way, of course, is improper equipment. Equipment can fail, which is one of the reasons why we inspect our equipment very clearly. We have to make sure we use the proper equipment. There's two types of lanyards. There's actually three types of lanyards. There's one which is a fall prevention. There's one that arrests your fall. And then finally, there's one that we use for positioning so that we can let go of the structure with our hands and be free to use both hands to do the work. So we need to make sure we have the proper lanyards being used and that they're installed correctly and that they're not going to fail. So it's not enough just to have a lanyard, you have to latch it onto something. And that something has to be able to hold you in case you fall. In the Wind Systems Technician 1 class, we'll talk in much more detail about the equipment and the ratings for them and how they're used. So I look forward to seeing you there. There's also a type of a device that's known as a fall arrest system. So I'm going to go forward here to the book, and we're going to look at a couple of these. So bear with me here. All right, so this is an older shot here, 1979. That's the year I graduated from the Navy, and this is an old Jacobs machine. It's a DC machine. We actually have one of these up in Custer at the MREA that I've worked on before. You'll notice these gentlemen are using pretty much lineman belts, right? And you'll notice that they don't have on much more than that. It looks like neither one of them are wearing any sort of gloves, and we can see that this is a guide tower, and so that somebody climbed up this, these two gentlemen did, and at least they have hard hats on. In this case here, the biggest issue is that they don't have on the correct safety harnesses. On the next page, we're going to see an example of a full body harness. Notice that there are D-rings in the back, which is where the energy absorbing lanyard gets connected with this energy pack. This is the end that gets connected here, this to the D-ring. The other end, it needs to be connected to wherever a rated tie down point. On the other side, the front side, notice there's also a D-ring in the front. Now the D-ring in the front is used for what's known as a fall arrest sleeve, and that's a couple more pages over. I'm just going to go to that now so we can see that. Okay, so this is a fall arresting sleeve, and so what we do with this is we run a cable normally up from the top of the tower all the way to the ground, and this is going to hook on the D-ring of the climber's harness, and this will allow, if they fall, they fall just a limited distance, not very far at all. Only the slack in his harness is how far you will fall. And so we're going to put this, I've installed several of these. All new towers have them installed with them. There are many towers that don't have them yet, and so there will be retrofits that you may be involved with. You'll notice on this other picture here that notice the size of the D-ring on this one here. This is Nils, and he's got what we refer to as a pelican hook. It's a large snap hook, which makes it really easy to clip over. In this case here, what you would have to do in a case like this, if there were no climbing arrest, is that you would have to have two separate hooks. And in this case, you can see that the one that would be to his right is hooked on somewhere. So he'll climb up a few more steps, and then he'll hook the one from his left up as high as he can, reach down and unhook the one on the right, climb up as far as he can, and do this, umpteen times until he gets to the top of the tower. So you can see how that can be a very cumbersome scenario, and why the fall arresting cable and sleeve, one of the common terms is called a LAD safe. That's what's shown here. So the LAD safe makes it a lot easier for a person to go up and down a tower. What ends up happening in a case like this is often somebody will become complacent and say, oh, I'll hook up when I get to the top. That'll be fine. Well, that's when mistakes can happen. So back on our PowerPoint, we're going to see here that we have to have proper clothing. I mentioned gloves. Quite often, you can run into bird droppings. You can hit. We're going to talk a little bit further about Mother Nature, but there's nothing like reaching up over a platform and putting your hand in a beehive. And so gloves would give you a small amount of protection, and it might be what you need in order to get to the ground without your hand filled with several bee stings. I want to point out one other case here. So this is a case here of a gentleman that I knew, Craig Porter. He taught with us up at the Midwest Renewable Energy Association and was hired by Ivy Technical College in Lafayette, Indiana. And about 5 years ago now, doesn't seem like it can be that long, he fell to his death in front of his students in the class. So, and here's a NABCEP certified installer. This is a guy who knows better. So what happened? I didn't get the details. I don't know what caused Craig to fall. I know that I've climbed before, and we always remember we always have a point. Make sure you're tied off twice. I always tie off twice. That way, if I move one lanyard, I know that the other one is still connected to something. All I can think is that Craig overlooked something. So there's three causes to this type of to falls like this. One, of course, is improper training, thinking that you don't need that, you can just climb. Another one might be complacency. oh, it won't happen to me. And third, of course, can be mechanical failure. Mechanical failure. Stuff breaks. Stuff breaks all the time. Or maybe I don't install it correctly. When we get in our Wind Systems Technician 1 class, I'll show you how when you can put a lanyard on, sometimes the carabiners, if installed incorrectly, can actually slip open. I'm listing guy wires here. Guy wires are used for keeping non-monopole towers held straight in the air. We also use those guy wires for lifting a tilt-up tower, and those can part. If the winch continues to pull when if a guy wire has been installed incorrectly, and as you lift this into the air and it gets closer and closer to upright, if the opposing guy wire is too short, it won't be allowed to be lifted high enough. And I've actually seen carabiners break. I have a photo of that I'll show you in the wind installation class. What else can break? Welds can break. All sorts of hardware can break. If hydraulic were to leak, if a hydraulic fluid were to leak, that could also cause mechanical failure. What seems to be mechanical failure may actually just be a hydraulic cylinder or failing and causing stuff to move that you didn't think was going to move. Most people, when they think of wind towers, wind turbines and towers, they think of being afraid of heights, and it must be so dangerous to climb up there. The dangers from climbing towers are far less than what happens with tilt-up towers. A tilt-up tower is subject to all sorts of forces and wind, and it's got a lot more real estate involved as far as the lifting and angles and so forth. And so when we're doing this work, we have to make sure that we're careful to know our escape routes when we're on the ground, because if I'm raising a 150-foot tall tower using a bunch of wires and it tips over, those wires are falling with the tower, and think big cheese slicer. And so you'll get the point here as to why these can be dangerous. Anytime we're dealing with cranes, there will also be issues. Someone's got to tell the crane operator how to operate. In addition to your own equipment breaking, you also have the unknowns of how well has that crane been maintained, and will anything fail on it. Cranes are heavy. Is it possible that the footing where the crane is sitting isn't strong enough to hold it? And what would happen then if the crane tips over while it's lifting up a tower or a turbine to the top of the tower? Everything goes over with it. So there's some obvious issues there. Electrical shock. Well, if the turbine is going to be grid tied, depending upon the voltage, we may have very high voltages, we may have low voltages. Could be AC voltage or DC voltage. We could also be tied to a battery bank. So we have to make sure that we follow electrical safety and lockout tagout. Very important that we do that. If it's a large utility scale turbine, it's possible that it's near the end of a line, and by a line I mean a utility service line, and so it's possible that the length of the wire causes an inductive reactance imbalance, and if that were to happen, then it's possible that we may need to install some power balancing capacitors. And the capacitor is an energy storage device. It stores a voltage. And so even though we've disconnected the power, unless we discharge those capacitors, it's possible for them to shock us. Same thing holds true with the power supplies inside much of the equipment. Yes, we may have shut it off, but if there are capacitors inside which are used to filter and regulate the output of the power, they too can hold a charge. Mechanical release of energy. There's a page I want to show you in the book here that has a pretty good example of this. It's 373. That's a neat shot, isn't it? But that's not the one I wanted to show you. Let's look at this one here. What do you think? Anything possible go wrong with that one? There's a wooden work platform. Probably safe. Not so sure. I'm thinking that the trees aren't going to fall down, but boy, you never know about that platform that's nailed to the top. Okay, one more page over. All right, so in this shot here, we've got a boom or an aerial lift. These are very common. Yes, for even the tall 300 footers, there are lifts which can go this high. And notice in this shot here that we've got, it looks like some sort of a tie-down device right here on one of the blades. I'm not sure what that is, but in this case, there's two issues I wanted to show here. So is it possible that the boom is going to be okay? Or could there be a failure there? And then also, if possible, maybe we could use some sort of a mechanical tie down so that the tower doesn't, so that the turbine doesn't begin rotating while I'm trying to do the work on it. Scary stuff happens, man. So we have to also remember never to climb a tower with a spinning rotor. I don't care. If it's spinning, you don't climb up there. One of the issues in the book was told that a person was killed trying to install trying to stop a rotor that was spinning wild. So other things that can happen here, in addition to the rotors that could spin, quite often it would be possible to do service on, for example, the brakes or a yaw system or a pitch system. And by doing service on that electrical work, it might be possible to release a voltage that was holding something from moving. And if that part moves, it could pinch you, it could fall, it could spin, and you could be injured. Mother Nature's a big one here. If you're climbing and you hear thunder, get to the ground. If you hear thunder, don't climb. When it rains, surfaces get wet and it can be difficult to work. The wind, obviously. When the wind is blowing too strong, you don't climb a tower. In the classroom environment, if the wind is blowing more than 15 miles an hour, I won't climb. That's not the same standard you'll find in industry. In industry, they climb up to 20, 25 miles an hour, depending upon the area, because the work has to get done. There was a great show called, what was it called? It was called Turbine Cowboys. Turbine Cowboys was a show that was put out by the Weather Channel several years ago, and they had a episode where a young man climbed to the top of a tower, 300 feet in the air, was doing some work underneath, and was bitten by a rattlesnake. Well, how the hell does that happen? Well, it was a new installation, and the tower and the turbine were laying on the ground for a month or so before the thing was installed. It was in the desert, and the snake thought it was a great place to go up and hide, and so in it went. And so this gentleman was bitten by a rattlesnake, and he was lucky to be alive. His partner got him to the ground, and he was rushed off to EMS, and luckily he survived. So if you have a chance to look up Turbine Cowboys on YouTube, you may be able to find that episode. What else can you run into? Birds, bees, raccoons, all sorts of other critters can be there too. So be careful of those. Other parts about Mother Nature, of course, the wind, the sun, frostbite. You can get really hot, you can get really cold. You have to make sure that you adequately hydrate in both warm and cold conditions because that can really lead to fatigue, and fatigue can lead to improper thinking, and improper thinking can cause death. And then, of course, with the advent of all the ocean-going turbines, it might be possible that you'll be working on a site that's out there. So far more conditions are going to exist there where you may end up having to be helicoptered into the turbine. You may have to go using a boat and make your way into the tower. And so there's some other things that maybe you haven't thought of there. And lastly, let's talk about travel and fatigue. A lot of times these turbines are in the middle of nowhere, and so you have to drive quite a long ways just to get there. And maybe you've got a job to do that is a 10-hour job, but it took you 4 hours to get there. And so 10 hours is really too long of a day, you'd think, to continue working. But rather than make another 8-hour round trip job travel the next day, it's not uncommon for you to stay and work an extra long day so that you don't have to travel back for a short day. Quite often these locations have very poor road conditions or no roads themselves. And one other problem that occurs with this type of work is if you're staying in a hotel and you're on the road a lot, maybe you don't always eat well. And so you have to really be careful with self-care. So please make sure you read the textbook over. There's a lot of things that you would want to look at here. And I only covered a few of them. And I look forward to seeing you in future classes. And that's all for now.